Hello, good evening everyone. Today we are going to discuss a science topic density. Density it plays a major role in calculations like while doing latent heat of vaporization, latent heat of fusion, etc. While doing all those and also specific heat capacity, etc. While doing those calculations, density will play a major role. Even though it is a simple topic, during conversions of units, etc., it plays a major role. So we have to learn density. Okay. Now, without doing any late, going into the topic density. Density means here, see, density is nothing but a physical property of matter and it helps us to understand how particles are packed inside a material. So, when we observe some things like wooden box and concrete wall, even though both are having same size, their weights are different. That is where density plays a major role. See here, some particles are heavier than others, even when they are the same size. So, density explains why ships float. Even ships will float on water, and also helium balloons will go higher, and ice floats on water. And also, metals are usually sink in water. Why all this happens? Here, where major role of density we will study. Density is connected with how closely particles are packed together inside a substance. And a substance with the tightly packed particles usually has a high density, while a substance with particles spread far apart has a low density. Next, see here definition of density. Density is defined as mass per unit volume. This is nothing but mass over volume. So, see here. This means density tells us how much matter is packed into a certain amount of space. Means in particular volume, how much mass is packed. That is density. The greater the mass in the volume in a given volume, density will be higher. Density here will be directly proportional to mass and inversely proportional to volume. So whenever mass increases, density will be increasing. Whenever volume increases, density will be decreasing. See here, density equals to rho, density represented by rho equals to mass by volume. Here, rho is the density, m is the mass, v is the volume. Next, SI units of density. The SI unit of density is kilogram per cubic meter, that is kg per meter cube, and other units are gram per centimeter cube or gram per milliliter. And while converting kg per meter cube, 1 gram per centimeter cube equals to 1000 kg per meter cube. So this conversion is important in physics, chemistry, and engineering, and also in medicine. Next, understanding density through particles. The density of a substance depends on the arrangement of particles. See here, in case of solids, particles are tightly packed and also force of attractions are strong. Density is usually higher. And in case of liquids, what happens? Particles are close together, but they are not closely packed. So particles, but can move. Even though they are packed together, they can move. And density is lower than solids. When compared to solids, density for liquids will be lower. And even it comes to gases, particles are far apart and density is very low. Next, this particle arrangement explains why gases occupy large spaces and why solids feel heavy and compact. See here, next, relationship between mass, volume, and density. See here, density increases when more mass is packed into the same volume. Yeah, if you are having two volumes same, see here, both are having same volumes, and here particles like this. Here like this. Here same volumes, but here particles are close together and particles are less. So same volume. Mass is different. Density will be higher for this one because mass is higher. Density will be lower for this one. Next, see here. If volume stays constant, increasing mass increases the density. And if mass stays constant, increasing volume will be decreasing because density directly proportional to mass. Density directly proportional to mass. If density mass increases, density will be increasing. And density inversely proportional to volume. Inversely proportional represented by 1 by volume. Next. For example, a sponge and a metal block have the same volume, but the metal block has more mass packed inside it, so it is denser. Next, rearranging the density formula. See here, we can find the mass and volume when we have known the density. See here, rearranging the density formula. The density formula can be rearranged depending on the what quantity needs to be calculated. See, mass equals to density times volume, and that is m equals to rho v, and volume equals to mass divided by density, that is v equals to mass divided by rho m over rho. Students should practice rearranging formulas carefully because formula manipulation is commonly asked in examinations. Yeah. Next, measuring volume. See here, measuring mass. Measuring mass will be done by using electronic balance or beam balance, and it was measured in grams or kilograms. And while measuring mass, we should zero the balance before using, and also measurements should be taken carefully. Units must be always written because sometimes we may measure in grams and we may write kilograms. So those differentiations will come. For that reason, we need to we need to write the units always. Next, measuring volume of regular solids. Regular solids have definite shape. Yeah, we know regular solids are nothing but having fixed shape. For those shapes, we can find the volume easily. See here. For a cuboid, volume equals to length into width into height. And for a cube, volume equals to side cube. And for a cylinder, volume equals to pi r square h. Next, measurement should be taken accurately using ruler, vernier calipers, and also micrometer screw gauge. Next, the correct unit for volume is centimeter cube or meter cube. Next, for irregular solids. Irregular solids means they won't have particular regular shape. They will be like this. This is a stone, and for these solids we need to measure the volume. We don't have any formula because they don't have any fixed shape. So in such cases, what we do, see here, irregular solids do not have a simple mathematical formula for volume, and their volume is measured by using water displacement method. Yeah, see here, fill a measuring cylinder with water, record the initial water level, and lower the object carefully into the water, record the final water level, subtract the initial level from the final level. The increase in water level gives the volume. See here, they have given you an experiment. We will just see that experiment. See here. Suppose I am having a volume like this. This one is, I need to find the volume of this one. Now what you have to do? You have to take a measuring cylinder or beaker something, and you have to keep the water level up to something. And first note the initial water level. That will be 50 ml I am thinking. Initial water level I am writing it as W1 water level. And after this recording the initial water level, then throw the stone into here. Now here stone I have thrown, and the water level be increasing up to 75 liters. So W2 will be 75. Now what you have to do, final water level minus initial water level, then you get 25 ml. This will be the volume of the beak, whatever the irregular shape we are having. So this can be found by using water displacement method. Next, and then we can take this volume and we can find the mass and densities. Measuring density of a solid. See here, measure the mass of the solid and measure its dimensions or volume, and then calculate volume. Use the density equation. See, mass is 20 kgs, volume is 0.025 meter cube. So I need to find the density. Density equals to mass divided by volume. So 20 over 0.025, we will get 800 kg per meter cube. Like that we need to do. And density, measuring the density of a liquid. To measure the density of a liquid, we measure the mass of an empty container. And what we have the problem is, in case of irregular solids, we can't find the volume. That is difficult. And when it comes to liquids, in case of liquids, we can't find the mass. Suppose some ml of water. First, what you need to do, you need to take an empty beaker and keep it on the balance, and you need to find the weight of the beaker, W1. And after, pour this water into that beaker and then measure the weight, then you will get W2. W2 minus W1 means beaker filled with water and minus empty beaker weight will give the W2 minus W1 will give the mass of that liquid. So in this way we need to find. See here, measure the mass of an empty beaker and pour the liquid into the container, then measure the total mass, find the mass of the liquid. Measuring the liquid volume using a measuring cylinder. Next, then we can calculate the density. Example, mass of an empty beaker equals to 51 grams and mass of beaker plus liquid is 145 grams. So volume equals to 120 centimeter cube. First you need to find the mass of liquid. 145 minus 51, you will get 94 grams. And then density will be 94 divided by mass by volume. That is 94 divided by 120. You will get 0.28 gram per centimeter cube. Next, floating and sinking. Whether an object floats or sinks depends on the density. See here. Objects float if density of object is less than the density of water, then objects will be floating on the like ice, etc. And when object sinks, here density of the object is higher than the density of water, then object will be sink. They, for example, metals will sink in water because they are having higher density when compared to water. Next, water has a density of 1000 kg per meter cube, that is 1 gram per centimeter cube is the density of the water. And this principle explains floating ships, submarines, icebergs, life jackets, etc. Next, why ice floats? See here, ice floats because solid water ice is less denser than the liquid water. Means ice will be having low density when compared to liquid water. So when particles freeze, the particles arrange in an open structure, spaces from below particles, density decreases. This unusual property of water is important for aquatic life because lakes freeze only at the surface. Next, effect of temperature on the density. Heating affects density. When a substance is heated, particles gain kinetic energy and particles move further apart. Volume increases and density decreases. See, when temperature when temperature increases, particles will gain kinetic energy and they move further apart, and volume will be increasing, density will be decreasing. When particles are cooled, particles will when material is cooled, then particles will be moved together and density increases. Hot air balloons rise because hot air is less dense than cold air. Real life applications of density. See here some examples. Ships float you because their average density is less than water, and hydrometers measure the density of liquids. And oil floats on water because it is less dense. And life jackets contain low density foam. Helium balloons rise because helium is less dense than air. Next, density is also important in engineering, construction, medicine, aviation, geology, etc. Next, common errors we do in calculation of density. See here, sometimes we may forget units. For example, if we are taking the mass in grams, then we should take the volume in centimeter cube or meter cube only. Uh, like this, see here. Both units should be either SI or see either kg per meter cube or we age either kg and meter we have to take or gram and centimeter. If we take kg and centimeter cube and gram and meter cube, that will be wrong. So we have to check what we are taking. Next, incorrect volume conversion and also mixing kgs and grams, using wrong formulas, forgetting to subtract container mass. Always write formulas first and show calculations clearly, include units in final answer. Next, key definitions, see here. Mass per unit volume. Mass equals to amount of matter in a substance, volume equals to amount of space occupied by an object, and matter equals to anything that has mass and occupied space. Next, quick revision points. See here, density equals to mass divided by volume. SI unit is kg per meter cube, and solids usually have high density. Gases have low density. Heating lowers the density. Next, objects floats if less dense than water, and water density equals to 1000 kg per meter cube or 1 gram per centimeter cube. Density depends on the particle arrangement. Next, see here some practice questions. Define density. Density is nothing but mass over volume. And state the SI unit of density, that is kg per meter cube. Calculate the density of a block with mass 40 kgs and 0.02. So, mass by volume 40 by 0.02. So what we do, 40 into 100, converting the denominator into 2, 220. So density will be 2000. We have to check whether we have taken the units correct or not. 40 kgs, 0.02 meter cube. So 2000 kg per meter cube is the density. Next, explain why ice floats on water. Why ice floats on water? Because water is high denser than ice, so ice will be floating whereas it has low density. Describe water displacement method. That is nothing but measuring the mass of volume of the irregular solids. That is, we have to take a beaker full of some level of water, and then we have to keep this irregular solid into that water. Then we have to measure the rising water level. Final water level minus initial water level, we can find the volume of that. So this is water displacement method, measuring the volume of a irregular solid by using water displacement. State two applications of density. Applications of density, it is used to explain why materials of same size are having two different weights, and also it is useful in engineering, medicine, etc. Next, why does hot air rise? Because when air is heated, the particles will move apart and density will be lesser, so it rises. Next, a liquid has a mass of 90 grams and volume 100 centimeter cube, so density will be 90 by 100, then it will be 0.9 gram per centimeter cube is the density. Explain how particles arrangement affects density. If particles are closely packed, then density will be higher. If particles are loosely packed, density will be lower. Why do gases have low density? Because particles are atoms in the gases are loosely packed, they are free to move, so that reason they have low density. Next, summary table. See here, density rho equals to mass by volume, kg per meter cube is the unit. Mass is the m equals to pv, kgs or grams, and volume equals to mass over rho, that is meter cube. Okay, thank you, bye.